Hi everyone. In this video we will take a look at the process of distillation. But before we go into the details of what distillation is, I first have a question for you guys. Till what percentage can you purify alcohol by distillation? And if there is a limit, what is the cause of that limit? Think about it and see if you can get the answer at the end of the video. Now, distillation is a process that is used, just like filtration, to separate substances from one another. However, with distillation, we will be using different boiling points of molecules rather than solubility. In this video, I will show how it works with alcohol. Also, I will show how you can calculate the percentage of purity of the substance. This way you can measure the success of your experiment. For this experiment, we will use denatured alcohol of 70%, a distillation apparatus, a scale, a volumetric flask, and a hot plate. As mentioned, the alcohol is denatured, which means that you cannot drink it. This way it can be sold without having to tax the alcohol. It is 70% and we will try to make it a higher percentage. In other words, pure. The purified alcohol we then have can be used in the lab for other processes, such as solvent. The first step is to check the mass of the alcohol to see if it is indeed 70%. You do this by measuring the weight of the 100 milliliters of alcohol from the bottle that you purchased and divide it by 100. It turned out that it was actually much purer than the 70% that they said at the bottle. It was more along the lines of 80% pure. It is always good to check these things and to check your numbers to make sure that you are working with the correct numbers. After this, we put together a distillation apparatus. In this case, I bought a simple distillation apparatus at Amazon for about 80 euros. It is good for the exercise, but as you can see, the connections are basically stoppers made of rubber. For the future, I may invest in an apparatus that is connected with glass, since the rubber stoppers are not fully isolating. The alcohol, when it starts to evaporate, basically went through it a little bit on the side, and gas is basically poured out. This caused some of the alcohol vapor to get out, which means that I was not able to catch it and later liquefy it. And this resulted in less pure alcohol than I may have wanted, and loss of alcohol. So, what are we doing here exactly? Well, we put the alcohol in a round bottom flask and we start to heat it to that boiling point. As you can see, there is also a thermometer present to make sure we know when to stop boiling the alcohol or the mixture in the round bottom flask. Alcohol boils at normal pressure around 79 degrees Celsius. So, as long as the temperature is showing around 80 degrees Celsius, we are vaporizing the alcohol. However, if the temperature starts rising quickly, we can be sure that we now have reached a point where all the alcohol is mostly gone and we will start to vaporize the water and other molecules that basically stayed in the round bottom flask. Since we are only interested in the alcohol, that is the moment we will turn down the heat. So, what happens with the vapor then? Well, the vapor goes through this beautiful swirling tube, which we also call a condenser. Now, you can connect the condenser to running water to make it cooler in there, but I've decided to do it slightly different in this case. After the vapor will cool down, it will liquefy again inside of that tube, and the alcohol will start to drip from the inside of the Erlenmeyer flask that I surrounded with ice to cool it off there. In theory, the alcohol we will capture will have a higher percentage than we will have when we started boiling it. As you can see, I tried to use a bowl of sand first, but since the sand worked quite isolating, it took way longer to heat it than I wanted it, so I basically took it away. You can see the alcohol is slowly starting to boil and vapor start to rise from the boiling flask. At the other end, you can now see the alcohol dripping in the Erlenmeyer flask. We will need about 100 milliliters to be sure to make accurate measurements. While the alcohol is vaporizing from the mixture, you can see that the solution is getting less and less clear, indicating that what remains in the flask is, besides water, also something else, very likely some products to denature the alcohol. As you can see, the vapor that liquefies inside the condenser is also boiling. This creates a beautiful zooming sound which I was not able to record properly. After about 2 hours, we managed to get about 100 milliliters of purer alcohol, and I let it cool down for the night. The next morning, I was able to weigh the alcohol, and it turned out to be between 92 and 93% pure alcohol. And this brings us to the question from the beginning. To what percentage can you purify alcohol by distillation this way? And if there is a limit, what is the cause of that limit? Well, the limit will be, under normal circumstances, 95.6%. But now immediately raises that the question, why only 95.6%? Well, that has to do with the fact that how alcohol molecules behave. They love themselves some water. So that means that molecules of alcohol always try to get in touch with some water. And the boiling point, however, of the concentrated alcohol overlaps with the boiling point of water and alcohol. So, at some point, you will be vaporizing both. Now, there is a way to purify it more, but that is much more complex and unfortunately beyond my current skill set and lab capacity. This form of alcohol, or ethanol, is called anhydrous, which means without water, or anhydrous. It also is more difficult to store these solutions, as the water from the air will immediately want to form bonds with the alcohol again. So, that was the episode. I hope you enjoyed it. And if you have any questions, leave them in the comments. And if you liked the video, hit the like and subscribe button.